Hi everyone, this is SentinelLLM, a production-grade observability and security gateway for LLM applications. Today, most LLM apps behave like black boxes. You can't see what prompts cost, why latency spikes, or when something goes wrong. SentinelLLM helps solving this problem using Datadog APM and Google Vertex AI Gemini. LLM applications are incredibly powerful, but they are also expensive, unpredictable, and hard to debug in production. Traditional monitoring tools don't understand LLM behavior like token usage, prompt security, or model level rate. Our solution adds up to LLM awareness, observability, security checks, cost and latency visibility, Datadog APM integration. Our architecture sits between the client and Gemini. Every request flows through this fast API gateway when we perform security checks, measure latency and tokens, and send full telemetry to Datadog in real time. Our key features: real Gemini 2.0 calls, token and latency tracking, prompt security detection, Datadog traces. Our Datadog integration steps. Now let's dive into live demo. This file sets up observability for the entire system. Here we instrument the application so every LLM request emits latency, error, and performance traces directly into the Datadog. This is what turns LLM behavior from a black box into something we can actually monitor and debug into the production. Routes.py is the main gateway endpoint where a user prompts enter the system. Every request goes through security checks, Gemini interface, and telemetry captures. This ensures every LLM interaction is observable, measurable, and traceable end to end. This file wires everything together: the API, telemetry, and lifecycle management. It ensures observability is enabled automatically as soon as the service starts. From here, Datadog can discover the service and build traces without any manual configuration. Now I'm going to start the live Python file of LLM client to start the server, and you can see what happens. It shows the environment variables have been initialized and the LLM gateway has been established. Now we go to another terminal and send few requests, requesting for the integration of data and the data transfers, and you see a Gemini prompt and a conclusion occurring in the meantime. Here you can see the Datadog agent running locally in Docker, acting as a telemetry injection layer. All traces, metrics, and logs from SentinelLLM flow through this agent before appearing in the Datadog APM. This curl request simulates a real client calling the generate endpoint with a prompt. It is handled by the fast API gateway, forwarded to Gemini, and returned to the client. At the same time, the server emits traces so we can solve exactly how the LLM behaved. The request that flows through SentinelLLM hits Gemini, and the full lifecycle, latency, tokens, and execution is captured on the server and sent to the Datadog in real time. As you can see, the client is hosted live on the Ubicon server on the local host of 8080 port, and these are the Gemini results and the Gemini log file results being showed. A local host doc review is being showed right now. Once in Datadog dashboard, we go to APM traces and go to the services. The services in Datadog are derived from traces not manually configured. This means SentinelLLM becomes observable the moment it handles the real-time traffic. Drilling into the service, we can see every request handled by the LLM in the SentinelLLM service as shown. Each trace represents a full LLM interaction from API entry to model response. As you can see, the time spent, the expenditures, the errors, requests and errors, and latencies. Now we go to traces. This is a view where we can inspect every individual request handled by the SentinelLLM. Each trace represents one complete LLM interaction. When we apply filter, the SentinelLLM serves to focus only on LLM gateway traffic. Opening a trace shows a full execution path of a single request. As you can see, this includes the API, entry point, processing time, and downstream models. The timeline breaks the request into spans so we can immediately see where the time is spent. If latency increases, we know exactly whether it's the gateway, the model, or something else. This lets us debug performance and failures at the level of individual LLM request. That's critical for operating LLM systems reliably in production. Henceforth, this turns LLM behavior from a black box into a fully observable system. This is the LLM service dashboard where you have selected the SentinelLLM, and now you can see all the service summaries from requests and errors to latencies to uptimes to downtimes to time spent to charges to all sorts of durations. You can view the infrastructure dependency and deployments, and you can view the traces too as well. This is a live showpiece of the get and the post requests. This is a live infrastructure review. Henceforth, at the end, we have also connected the Google Cloud Console, and we have configured the Datadog and the GCP and a local model. Thank you.